Good morning, everyone. We welcome you on behalf of Western Digital and OpenE, myself, Cagatay, and then my colleague from OpenE, Marcin. We would like to present you some recently built interesting solutions today, combined solution of Western Digital and OpenE. My name is Cagatay. I do the business development, the technical business development for solutions, and Marcin.
Yes, hello, good morning. My name is Marcin Galeja, process engineer from OpenE, and today we want to show our data storage software solution, JovianDSS, combined with hardware from our partner today, Western Digital. If you will have any questions, you can use questions panel or send it by email. That will be visible on our title slides, and we'll of course try to answer your questions as best as we can. Cagatay, tell us a little bit more about what you prepared for today.
Right. Okay. So for the sake of familiarity and from the beginning, so what do you expect today? So from the Western Digital side, I'm gonna tell you a little bit about the history, how the SDS or the software-defined storage came up, and how does it really look like from a hard drive and an SSD manufacturer perspective. Recent products that Western Digital is investing, developing to support the SDS-based solutions. And Marcin is going to show us Jovian and how it is integrated with Western Digital Data60, Data 102, but in a live demo. Also, we will show you the feature sets and then storage backend, backup, virtualization, and replication, ending up with live demo. Feel free with your questions. We will be honored to answer those questions. And let's go to the hardcore, right? So as I mentioned, SDS, what it is and what is not. For historical reasons, software-defined storage is still a question mark for people, the older generation like me. You know, why? What is SDS? Why software? What defines software, right? And how it becomes the storage. Actually, it is very, very easy. But just for comparison, I'm just gonna I'm going to invent a term which doesn't exist, okay, the hardware defined or the conventional storage. So in a conventional storage, most of the time it's a box. It's an enclosure from a vendor. And in that box, you see very common hardware, right? It's very common hardware. It's typical processors from the processor manufacturers. It's DRAM. You have the common connectivity, Ethernet, fiber channel, and then you have the redundancy control in terms of hardware or software RAID or the HPAs. And all this around, this is packed up with a bunch of hard drives, either flash or SSDs, right? And everything put together and run and managed by a proprietary software, right? That makes it hardware because it comes from one hardware manufacturer, right? Well, it's worked fine until now, right? In the last, say, 20-ish years, the hardware defined or hardware-based storage was working fine. So what happens now? Well, the driver of the new need is scaling up and scaling out, right? So increasing capacity in the individual enclosures and then putting many enclosures together. So and then still make it work. That is becoming a challenge. The flexibility, because you're tied with one software from one vendor, and it doesn't really work well with other piece of hardware. So you're very much tied. So it takes all the flexibility out, and the cost, right? You're very much entitled to continue grow, consuming your requirements only from that vendor. And if you don't have a good experience, bad luck, right? I'm not saying like hardware-defined storage is bad, but you know, depending on your needs, if you have made the wrong choice in the beginning, you have to suffer with. It feels like a wrong marriage, you know. You're just entitled until your last day, unless you go for a divorce with that person. You just come together, right? This vendor dependency is also so if you need a feature and then that feature is discontinued or it doesn't support, or that need of that specific feature arising in the time and it's not there, again, bad luck, right? So on top of that, STS, the software-defined storage, is future rich, right? And then the features coming from one generation to the other is very easy, very efficient. It's hardware agnostic, so it is not really tied to the hardware of one particular hardware manufacturer. The only thing you need to make sure that your STS provider already tests that hardware and then make sure that it is working, like we have done. We have done with OpenE, our Western Digital JBOD enclosures. We've tested and then all certified. Scalability. So it scales nicely and very efficiently, flexible. You can scale up and scale out. We can support distributed architectures depending on your performance needs. If your performance need grows by time, now you have more users, you have a bigger capacity to manage, you can always grow with STS in a much more efficient way, right? And then you adjust your performance based on your application needs. An interesting slide showing like the conventional, traditional hardware-based storage was quite dominant in the last decade, but the last couple of years, that piece is really reducing, and it has been replaced by the hyperscale cloud-based solutions as well as the enterprise software-defined solutions. And OpenE is a very strong member of playing in both green and orange piece, which are you could use the solutions of OpenE on cloud, on-prem, and then both works very fine. Right. A few words for the Western Digital. Western Digital has been a historical company of innovation, starting from the very early hard drives, which is it's an IBM, which has been in the chain acquired by Western Digital, going to the first micro SD cards, first compact flash, first helium-filled drives, which allows today's high capacity, high density HDDs. So Western Digital has been an innovation house. And besides the innovations, we also have a very strong patent portfolio versus, Western Digital with the patent portfolio is ranking in the top list of the worldwide patent owners. And we integrate vertical, both our hard drives, starting from the heads, wafers, head gimbal assembly, media, everything put together. Similarly, our flash products starting from the semiconductor, which we are one of the few manufacturers of the flash wafers, until the final product, we build everything on our own in-house, which gives us a quite strong control on the quality, right? Hard drives, well, we are around more than 30 years, so probably Western Digital and hard drives are almost equal in many minds. We build different flavors of hard drives, and then recently we announced an 18 and then 20 terabyte being SMR. So we were the first one to offer the highest density, highest capacities into the market. Similarly, we have also a quite decent flash product portfolio, starting from the SATA boot drives, going until the high performance NVMe drives in AIC and then U.2 form factors, right? Now the core of my my speech is the platforms. The platforms are the enclosures Western Digital builds supporting STS solutions, right? So if you want to build your STS solution, we just make sure that you can add storage to that STS solution in the easiest way. So how does it work? So we can just plug through the SAS HBAs or RAID controllers to a decent number of the compute nodes, and then make sure that they get their required capacity. It can be done with zoning, can be done without zoning. You can make multiple nodes and then give access to the shared storage or common access to the drives. Well, there are many possibilities, which we will show in the live demo also how OpenE is handling, right? So the standard configuration is, we have, by the way, 12 SAS ports on the back, which are going on a high available or redundant IO modules. And each of those SAS ports are having access to all drives in the standard configuration. But we have also pre-configurations, a variety of pre-configurations, depending on your requirement. You can just as you see on the right side, color coded. So you can just move the access of the first 10 drives to A1 and B1 ports, or you can just make it like a 30-30. So the first half just goes into one compute and the second half goes into the second compute. So it gives you also quite decent amount of flexibility. And if you want to add storage in one enclosure, because you're tight in space, because you're financially bound, whatever, and still make an HA solution, this single enclosure will make sure that you have all the requirements of your HA despite, right? The technical innovations from Western Digital, we have a couple of patented technologies. First one is the flexible background. You know, the mechanical hard drives, they are well known to vibrate during their operation. This backplane is flexible and it lets the vibration emit on the spot without disturbing the neighborhoods. We have the thermal cooling, special thermal cooling channels in high density environments, like when you have like 100+ drives in one enclosure and they are very tight next to each other. So the cooling, the back rows becomes an issue. So we have separate cooling channels, which takes the cool air from the front and then redistributes from the mid to the back rows. That gives us a very decent operation temperature, right? With the help of these technologies, we have managed to reduce, and this is the tracking of, the blue line is our own platform returns. Return is something no one likes. You know, it's an upset customer, it's an additional cost, it's replacement, it's logistics, right? It's rebuilding data. So the more you can reduce the return, the better for everyone. So these are two tracking the other platforms that the Western Digital drives are sitting in versus Western Digital own built platforms, the JBODs. And then we are able to demonstrate that the returns we are recording are 2.5 times less, which means 2.5 times less headache, you know, for everyone. So the enclosures, all Western Digital enclosures comes with the 5 years bring-in warranty, and the Data60, Data102, well, obviously the number is the amount of the base. So they come with a hybrid, which means up to a certain amount, which is 24 SAS or SATA SSDs also can be plugged in, which makes again these platforms an ideal solution because STS love tiering. So STS solutions in overall, and then Marcin is also going to tell a little bit more about it. You're gonna need tier to get a better performance for flash, and that is also pluggable into the same enclosure. You don't need another enclosure. And the big brother Data102, it goes with 18 terabytes up to 1.8 petabytes. It's like almost 2 petabytes in one 4U enclosure. It's amazing. And you don't have any bottleneck because the way that we design it with the multiple expanders, the total available capacity can go up to 57 gigabyte per second out of this enclosure. You know, that's technical or theoretical maximum, and I think that solves many other people's problems, right? We are also offering Fabric-based NVMe solutions in a similar logic. So these drawers have a bunch of flash put together, and then it goes through an RDMA network or the RoCE. We support RoCE 1, RoCE 2, also with routing. And then those goes through, and then you can mount the required flash out of these enclosures to any server you want on the network, either on a direct attached storage or provided that you have a RoCE capable switch, then you can just book and mount your NVMe requirement to your individual servers from those enclosures. And that's an overall picture. We do innovation. We offer 5 years warranty. We offer the best-in-class support and services, and we give you the first to market because we test our hard drives first with our enclosures, obviously, right? So having said that, thanks for listening. I don't want to take more time because I want to leave the lion's share, the best part for the live demo. And Marcin, the stage is yours.
Yes, thank you very much, Cagatay. Let me change screen to my presentation. Yes, okay. So let me quickly go through presentation. As I said on my title slide, there is my email, contact email, so we can always use also you can also send questions to that email that is visible on the slide. So let me go through agenda for today. First of all, I will try to tell you a few words about our company, who we are, what is our goal, and how we want to position on the storage market. Next, we will try to check what is our architecture for today, how our environment is configured, how JBOD from Western Digital is connected with our software JovianDSS. Next, we'll go through our portfolio to check how we can manage all the requirements from business from all sizes. And next, key features of our main product JovianDSS. How we can position on virtualization market, how we can combine it with hypervisors, a few words about deployment examples, also with, of course, VMware usage, and last but not least, our one of the best feature on the offsite data protection, and question if JovianDSS can also replace or replicate your data securely to another location. And at the end, we will change the screen to our live demo, where I will try to go through graphical user interface of JovianDSS and show you particular components and how it works, and how, of course, administrator can easily manage it. Okay, so as OpenE, we are international. Oh, I don't know if you can see it. Okay, as OpenE, we are international multicultural company with main headquarters in the United States and the second quarter in Germany, in Europe. We also have branch offices in Japan and in Poland, so we are able to cooperate with more than 400 certified partners all over the world. We believe in partner channel, so we are trying to cooperate with our distributors and with our resellers, and not to compete and of course not to compete with them. And what is our environment for today? Western Digital Ultrastar Data60 JBOD with 24 disks, each 6 terabytes each, is combined with RAID Z1, which we will talk about RAID levels on few slides later, and that gives us about 151 usable terabyte space. That JBOD is connected to our hypervisor, to our VMware, where two virtual machines are connected to the JBOD, and on that virtual machines we of course have two JovianDSS nodes installed and configured as hyperconverged shared storage cluster. And one information about zoning that Cagatay also described earlier. We have here disabled zoning to achieve, of course, our goal. So HA cluster with shared storage. If we want to use other architecture, for example, architecture where when every node will have his own JBOD, then of course we can use zoning and divide that Data60 for two devices. So every node has his own JBOD to reach, of course, HA requirements. Let's try to check what is our portfolio. Our portfolio contains two products, JovianDSS and DSS v7. We will today mostly focus on our JovianDSS, but let me compare. Let me show you a few differences between them. First of all, most important is that JovianDSS is based on ZFS file system, which is currently one of the best file systems available. ZFS allows us to scale up almost to any businesses, even if it is public or private cloud providers, or if it is a big data center. So we can scale up, really scale up. Additionally, ZFS don't have unlimited maximum storage. In theory, there are of course maximum values, but in real life there are unreachable nowadays. So we have unlimited maximum storage and unlimited maximum volume size. We don't need any hardware write controller, because we are working on storage pools instead of logical volumes. So disks are connected directly to node. And what more, we of course offer HA availability for all protocols, for some protocols like Fiber Channel and iSCSI, and also for NAS protocols like NFS or SNB. If we talk about redundancy, we are using a native feature of ZFS. So we don't need, as I said before, we don't need any additional hardware write controllers, and we don't need to rely on them. We can configure few different redundancy levels. First of all, it's of course mirror, that is old one, RAID 1, and then we can configure free write Z1, Z2, and Z3, where that Z number is an information for us how many disks may fail in a data group. So we can easily configure it. One more information about redundancy, that we prepare some special write calculator that can be found on our website. So if you want to check which write Z1 in your configuration will be the best, or to check, for example, in your configuration what will be the usable data space, so you can always use that our tool that is based on our website, write calculator, and it will definitely help and show you helpful information. Few words about ZFS. As I said before, ZFS is one of the best file system actually available. It's mostly focusing on reliability and data integrity. So it is very good for any size of businesses, but also for large players, like I said before, for data centers or for example cloud providers. We work on pool storage model, so we don't need additional hardware write controller. And for example, we scale very well. So if you want to, for example, add new disks or add new JBODs for your production, then you don't need to reboot any write. You don't need to synchronize it, which can take, of course, a very long time. Just connect your disks or JBOD to node, create new storage pool, and that's it. And it is accessible to all your clients. Moreover, there are of course data can be accessible through both SAN protocols. Like I said, it's also available for Fiber Channel and iSCSI, and also for NFS, also for NAS protocols like NFS or SNB, and also redundancy multipathing for iSCSI is available, and network interfaces bonding for SNB and NFS. What we offer more in JovianDSS is, for example, the duplication and compression, which allows administrator to, of course, save some space. Next thing is corruption detection and self-healing, which take care about data integrity, and of course, if any issues if any issues is detected early, then that functions, that features can repair the data automatically and keep integrity data of as it could be. And at the end, on and offsite data protection, which we will take a little bit more in the next slides, but in a short, it of course allows administrator to create snapshots and replicate it locally on synchronize it to remote destination, and in that way we can of course create some backups of our data. As I said before, we are able to set up our environment as hyper-converged virtualized environment. So it is very, of course, convenient for administrator. It is very easy to manage. When in that case, of course, deployment is very faster compared to solution with hardware-based storage. And of course, less hardware is required. But most important thing is that we passed all certifications and we achieved VMware Ready certified solution. So we are ready to work with VMware cloud infrastructure. We are certified and we are compatible with current VMware hypervisor. So here are the link that you can check our compatibility guide with, of course, VMware. The slide will be definitely shared after the session, so you can find on this slide direct link to VMware compatibility guide where our products are positioned. And few deployment examples. Most simple example is of course single node, where there are only one node with JovianDSS installed, and disks can be as internal storage connected directly to server, or can be connected through a SAS interface or fiber channel via JBOD to node. Next one is first HA cluster is shared storage cluster. So here this is our configuration, our live demo. So JBOD are connected with two nodes with single storage, as you can see on the left, and also it is possible to configure dual storage where connections are crossed. And then each individual node has his JBOD connected, but of course connections are crossed, so all disks are visible to our cluster. And last deployment is most advanced, is Metro cluster, non-short storage cluster, where of course each node has his own JBOD, has its own disks as internal storage or as JBOD connected through SAS or fiber channel. And additionally, we can also configure replication through Ethernet between that nodes. So administrator can also create some replication path through Ethernet with direct connection, fiber optic connection. It can up to as I remember 50 miles. It's about 80 kilometers. So also with such long distance we can create some kind of replication through Ethernet. And at the end, we have feature on and offsite data protection. What is about with that feature? So administrator can backup and restore data with consistent snapshots, and then replicate snapshots asynchronously to local and remote destination. And that's all without any additional backup agent. It is native feature of ZFS. So we will show it later in live demo. But how it works? Administrator can create snapshot of whole data set of whole logical volume that will be stored on locally or send it through connected remote hosts. For example, in case of disaster, in case of flood, I don't know, in case of any failure, that data can be copied, can be replicated to another remote location. Okay, and now we can change screen to our live demo. Let me change it. Let me change it quickly.
Marcin, I have received a bunch of questions. Would you like to listen them now or after live demo?
Yeah, of course. We can check questions now.
Okay. While your connectivity to live demo is happening, so the first question came in: if there is no hardware RAID controller, where does the RAID-related metadata resides, and how quick are the rebuild times? I think this is the second.
Rebuild times, of course, is depending on size of volume, but all metadata, all RAID metadata is based on disks with JovianDSS. So all are located locally on the medium of JovianDSS.
Now, I think the question is, if I understand it right, it just wants to have a comparison of versus an hardware RAID controller, the rebuild time. Does ZFS offers an advantage, a quicker rebuild, or equal, or slower? My experience is ZFS is amazing.
Yeah, we need to remember that ZFS using his native it's his native feature, so it always be faster than connection with external hardware controllers, where of course some drivers need to be updated and some connections need to be started.
That's also my experience. And there is another one. Are there any guidelines available for the hardware such as DRAM and CPU cores versus the total capacity? So because you mentioned earlier there is a minimum hardware configuration for the JovianDSS,
yep.
right? But can I just plug like 2 petabyte behind that, or probably I need to have a different number of DRAM hardware and then CPU cores? Is there any guideline available on your website?
Yeah, so on our website you can find, of course, minimal requirements for JovianDSS in few examples, in few architectures, and then we have also a few examples, for example, with enabled duplication or with such amount of data. What is our recommendation, how hardware should be configured. So this is first. Second place is our list of our certified servers, where we have some hardware that we tested, that we benchmarked, and there are of course detailed information about configuration, and also there are a bunch of information about performance. So how many IOPS we can achieve with current configuration, for example, for data or for a database or for any other service that we tested. So this is second thing where we could check and compare it with our environment that we're planning to do.
Okay, so the best would be either going for the suggested hardware or sending an email to you to,
yeah, of course,
right?
Of course, you can also, if you send email to presales at OpenE.com, then we will change. Then we will check your current configuration. We have prepared some special pre-deployment form that you can fulfill, and we will then check regarding to your planet architecture and regarding to your planet topology and planet usage of application. We can check if it will be okay, or if you need to change something in your configuration. So the best option is to always send us an email to check that configuration, and after confirmation we can of course proceed to next steps.
Okay, there are more questions coming in, but I will have one more and then I'll let you go because the live demo is important, right? One says there are integrated backup. So does customer not need any more an external or third-party backup software? Does Snapshot cover all the requirements, or a third-party backup software is still required? And if in that case, are there any suggested or integrated?
Well, yeah, we don't have any integrated third-party backup solution, but of course it depends of your requirements. If you need more detailed backup solution with more advanced features, then of course you can always use a third-party backup solution. What we offered is using native ZFS features, like for example snapshots, and that snapshot, as I will show you in live demo, will allows you to restore, to rollback data to its previous versions, or it allows you also to for example mount such snapshot into another data set. So you can mount it to your JovianDSS and at share check the data and then restore it. And that's how whole restoring and whole backup function works. And also, of course, it allows you to use remote destination. So it's very, in my opinion, very good option to avoid a situation where, of course, backup will be only kept in local destination, and for example, in some if some disaster appears, then there are no backup at all.
My experience also, snapshots work amazingly good with ZFS, with your products, and most of the time they are the most required part is for hypervising the virtualization. And if you have good snapshots that you can roll back, I mean, frequent enough, that anytime, I don't really see a necessity of having another backup. But thank you very much. And now let's show us the good things live.
Yeah. Okay. Okay, so now you should see my browser with two nodes first two nodes in cluster. Let me log into each.
I think your password is too short.
Yeah, it's a different password, but it's of course it's only our internal environment, only for that demo purposes. So
Okay.
so it's nothing hard to ask to check. But I don't know if my resolution is okay, because I have still some screen issues, but it's hopefully it is visually okay. Cagatay, can you confirm it?
Yeah, you're right now. I see that it pool 0, and then the pool
Okay.
Z pools available. That's where the screen is ending.
Okay. Okay, so as I described before, we have here 24 disks, 6 terabytes each, configured for that both nodes in cluster. So both nodes are so all disks are visible for both nodes. We are here configured write Z1. You can see in this group that we have here write Z1 with 24 disks. Which gives us about 131 terabytes available space. As I said before, that creating storage pool and adding new and deleting it, it's very easy and very fast. So we can, for our demo purposes, delete that 150 terabytes zip pool. It should take about, I would say, 5 or 10 seconds. So comparing to old-fashioned solutions which are basing on write controllers, then it's very fast. Yeah, as you can see, it is almost done.
So basically, you are initializing a storage of 100+ terabyte. Like just to compare, if you just initialize a storage, with any other tool regardless, it might be an hardware RAID or software RAID or anything, right? Just to initialize the capacity as such, 100+ terabyte. Here you go. It just take like 10,
exactly,
15 seconds.
exactly.
This
is
amazing.
And we can now create new zpool, and we will do it. We'll do it right now. And we can, as you can see, we have here our available disks. We can choose, for example, 10 of them. 10 of them, and we can choose redundancy level for this 10 disks. We can choose Z1, Z2, Z3, or we can choose mirrored groups, and we can put that 10 disks into one single mirror group or into multiple multi-groups, which will create automatically five groups with 2 disks on each, which will be configured as mirror. So we can choose that, click add group, and as you can see, we have here 5 groups with 2 disks each, which gives you about which gives us about 20, 27, 28 terabytes usable space. Click next. We can also use cache if we have faster disks, for example, NVMe, faster disks than for data. We can use also cache, which will of course increase our pool performance. So data will be written and read much faster. But for that demo purposes, we won't add any write log and read cache. So we just click next. We can also add spare disks, which will be, of course, could be replaced if any disk of failure reappears, but we want to do this also here. Name of the pool, summary of our configuration. So as we showed before, 5 groups of 2 disks. And when we click add the pool, then it also takes about 10 or 15 seconds to create working storage pool where we can instant create some share, and so users can access it without any delays. Yeah, so it's done. So we create now pool with 10 groups. With 10 groups of 2 disks mirrored. If we want to add another group, as I said it before, if you want, for example, connect new disks, as now we have some free disks, so you can always add to existing pool. You can add new group, add group. You can choose your disk that you already connected. So, for example, you can choose I don't know, that six disks, and add it to Z1 right? Add group. You can see new group that is here, and click apply, and it will be instantly added to your zpool. So you don't need to rebuild anything. We just adding disks. We just adding new data groups, adding new disk groups to our existing pool, and actually that's all. And we can create on that pool. We can create some iSCSI or fiber channel targets, or we can also create some shares. What we can do now, we can create new data set. Here are advanced properties of that data set. So we can enable or disable the duplication. We can change compression level. We can, for example, change record size or put some quota reservation. We will apply. And when we create data set, we can also create data set, for example, for backup purposes, for local backup purposes. So we will create also a backup data set, apply. And for data set, we can add share, for example, share 1. We can enable NFS or SMB protocol on it. So let me enable SMB. We can configure guest access, or also we can put it only on read mode. So we can put it only on read mode. Next, user access is disabled because we enabled guest mode. And in summary, we have properties of our new share protocols, and of course user access summary. And we can click add. We have here one share, so we can check if that share is visible. I don't know if you can see my. Let me.
Maybe you need to share the other screen. Yeah, that looks good. Yeah.
Yeah, it should be visible now.
Yes, your Windows screen. So you say share is already ready.
Yeah, share is already accessible for users. We can try to create some file, but of course we have set up only read-only mode. So now we can edit protocols and uncheck read-only, apply, and it will be immediately accessible to create, for example, new doc file test. Yeah, and we can here, for example, put some text from 1 to 5, close it. And what we can do on that share, and what we can do on that share is also create some backup tasks. What is called our what we can do on dataset, sorry, what is called our snapshot creation. So we can create backup tasks. We can put here a retention, how that snapshot will be taken every 5 minutes or every 15 minutes or every 1 hour, and how long it should be kept. For our test proposals, of course, we will change it to 1 minute. The other we can leave or delete. It doesn't matter. So a snapshot will be taken every 1 minute, and then we can set up multiple destinations. So it doesn't need to be only one destination, but we can set up multiple destinations. It should be replicated locally, and for example, for remote destination. And we can choose our destination server. We can choose some remote server, as I said before. It could be remote location, or we can choose local server and set where we want to create a backup. So for example, we choose our dataset backup that we created before. Now clicking apply, and another retention interval plan for destination place, how long it should be kept for in the destination. We can also change it to 1 minute also. Yep, for 1 minute. And as I said before, there could be, of course, multiple destinations. So there are no restrictions about that. We can integrate it with our vCenter or vSphere. Task properties we can leave empty. Summary. And after that, on our data set, there will be marks that this is destination source for backup and recovery task. It is not yet synchronized because not yet snapshot is created. And on the dataset, there are also marks that this resource has an automatically taking snapshots, and there is backup tasks configured for this particular dataset. And to check how it works, we can of course need to wait for 1 minute to first snapshot will be created. But in the snapshots menu, there will be you can see here snapshot of datasets, and you can see dataset 1 and backup. And here you will be able to see after 1 minute how snapshot is created. Yeah, so it is already created. So we can see it's automatically created snapshot with date and current hour. What we can do with that snapshot is, of course, we can rollback it. So there will be data will be automatically replaced on the source data set, or we can clone it. So we will able to create clone of that data set and mount it on new data set that will be cloned on that AutoSnap. So we can choose clone. For example, we can put name for clone 1 add, and that will be created. A new share. You can see it there. Dataset from automatically created snapshots. That is named clone 1, and on that clone 1 we can of course add share, so we can allow users to connect to it. For example, test 1 or clone 1. Next, can also enable SMB service. Next, same steps as before. Yeah, and now clone 1 is mounted, so we can just simply go to clone 1, no, clone 1 or clone 1. Yeah, and we can check what is the data on the current snapshot. If we change something on our share 1, so for example, if we put here or anything more and save it, so next snapshot that will be created, we have 45. Let's wait for another snapshot.
Oh, there is another question came in while we are waiting for the snapshot.
We can take it.
Right. You mentioned a remote location for snapshotting, backupping, and the question came in like, are there cloud protocols like S3 supported? So if I can take my snapshots in an offsite location, say Amazon, AWS, or Google Cloud, or anything else?
No, we currently don't support. There are no support for external cloud providers like Amazon or Google Drive or something like that. You can only put an IP address of remote location of remote JovianDSS, and it will be via SSH connection. It will be replicated to it.
Okay. I think we have the clone already. I mean the snapshot already.
Yeah. We have already cloned, so we can also clone that snapshot. For example, clone 2. And another clone 2 appears. Let's mount it so it will be visible via SMB. Yeah. So now if we go to clone 2, it's test 2. Okay. Test 2. Yeah. So we have data from that latest snapshot, and it will be containing that change data from that first snapshot that we take. So this is how snapshot working, and for backup purposes, of course, snapshots are created automatically, and you can always, of course, not for 1 minute, but you can also, of course, get back to data state of for example, before any failure or before any ransomware attack or anything else. And you can mount it to another data set and of course check if it is okay and restore data simultaneously. So this is how snapshot feature works. On tab backup and recovery, we have our backup tasks, so we can check which backup tasks are already enabled, and we can see that data set from pool 0 is replicated to destination path backup data set also on pool 0. So it is classical local backup, but if we change it to remote destination, then of course it will be much more safe. What more we can show here? It's of course failover settings. That nodes, as I said before, that nodes are working on HA cluster. So we have here failover status that is started. It is configured with that second node. With of course ring node with ping node, so whole configuration of failover and of all other our features are available also on our website through step-by-step documents where all steps are described in details with screenshots. So it is very easy to configure it. Additionally, we also prepared some webinars, some video materials that is also showing how to configure, for example, failover or, for example, backup and recovery tasks. It can always be found on our website. So you're welcome to of course visit our website and check that materials. And from cluster point of view, on the second node, there are information, of course, that pool 0 it's currently active on node A. I didn't change the name here, but this is node A. And of course, zpool is ready to import. So if we want to change pool, change for example, in case of failure, that's node A, we can always move pool to this node. So all clients will be automatically connected to that second node, and there are almost no data failure. It's about 5 to 10 or 50 seconds to change connections from one to second node. And so this is our failover times, which is also, I would say, quite good. Quite good times.
So actually, in terms of so this is a question from me. So in terms of the failover, technically you're not really moving the data, right? So it's just the control piece is just moving from one node to the other, and then there is physically access to that drives anyway, and the configuration of RAID and everything is already on the drives. So which means that you're just taking the control, and then within a second you're just ready to go from the failover, right?
Yeah, exactly. And same with Metro cluster, where connections, where application between nodes are made over Ethernet. All clients are connected to shares via virtual IPs in that case. So we actually don't need to change anything from client side because from client perspective it will be also always the same virtual IP for both nodes. So technically only node only information about pool is transferred between nodes and nothing more. So from administrator side, from administrator perspective, you don't need to change anything on clients. So it will be working immediately.
Very nice. Thank you very much, Marcin.
Okay, thank you very much. That's all from my side. Cagatay, can you maybe check if there are more questions on board, or there are no questions at all?
There are similar questions, but I think we answered all. So on behalf of Western Digital, thanks for joining us. Thanks for listening. I hope you enjoyed. With the intention of catching up with you with some new news, with some new products, new solutions together with OpenE. Looking forward to see you soon. And with that, I would like to say, yeah, stay safe, stay healthy, and see you soon. Thanks.
Yeah, thank you.